Hello students, today we are going to learn definite integrals. Okay, all this time we were learning indefinite integrals. So definite integral is all about taking limits. Okay, that is actually it is a area function. Okay, so that is, if integral means what, if you are given some curve. Okay, curve. Now we have to find area under this curve, and this we do using integrals. And definite integrals, in this we can take the numbers, that is limits, from where to where we have to find the area. Okay, so this we cut into small pieces. Okay, and then we take the limit. Okay, and whatever value, these values we add up together. Okay, small values we add up together. Okay, some function, so that we get the total area. Okay, so definite integrals, it uses fundamental theorem of calculus. Okay, so it is given by integral from a to b. So this is our limit. Okay, from a we are starting, at b we are ending. Fx dx. Okay, and after finding the integral, okay, this is your integral, you have to find the value by using limits. That is, this becomes f of b minus f of a. Okay, this is our desired area. So let's use this formula, okay, to find definite integrals. We'll solve some problems. Let's solve this problem. So first you have to integrate. So cos 2x, integral of cos 2x is sin 2x, and the derivative will come of 2x will come in the denominator. Okay, so this becomes our function integral, and you have to integrate from 0 to pi by 2. Okay, so this is your a, this is your b. So while taking difference, you have to start from b. So first you have to write b. So half you can take outside. Sine 2 into pi by 2 minus sine 0, right? So this will be half sine pi. Pi is 0 and sine 0 is also 0. So the answer is half into 0 is 0. Okay, let's solve this. So first you have to integrate. Okay, so 0 to 2, 6x upon x square plus 4. Okay, I'll separate out this. 0 to 2, 3 upon x square plus 4 dx. Okay, now this I can write 3, I can take outside. 3 into 2, so 2x upon x square plus 4 dx, plus 3 I can write outside. 1 upon x square plus 2 square dx. Okay, so here I can apply f dash of x upon f of x formula. So this will be 3 log x square plus 4, and here I have to apply 1 upon a square plus x square, which is standard result. So this will be log x, no, not log, this is x square plus a square. So this is 1 upon a is 2, tan inverse x by a. Okay, don't have to write c here, huh? So to put limits, that is from 0 to 2. Okay, now substitute these limits and see what you get. So right here, first I will take this function. Okay, 3 I can take outside, so this will be log. First you have to put 2, so 2 square is 4, 4 plus 4 minus log 0 plus 4, so this is 4. Okay, plus 3 by 2 tan inverse 4 by 2 minus tan inverse 0 by 2. Okay, so this will be log 8 minus log 4 plus 3 by 2 tan inverse 2 minus tan inverse 0. Okay, suppose you don't know the values, you can keep as it is. Okay, so I'll write here 3 log, this is log a minus log b, so log a upon b, which is again 2, so it will be log 2 plus 3 by 2 tan inverse of 2, I don't know the value, so I'll write it as it is. Okay, you can find out the values of tan inverse of 2 or tan inverse of 0 using inverse trigonometry. Okay, you can use that. So this is the answer. There are some properties of definite integrals. Okay, so let's see them. Okay, so if it is a to b f of x dx, you can keep the limits as it is. You can take another function, okay, another variable t. Then second is a to b f of x dx, so you can interchange the limits b to a, just you have to put here negative sign. Okay, suppose the limits are same, that is from limits are from a to a. This is a particular kind of problem. Okay, suppose the limits are from a to a, then this integral is directly 0. Okay, third property is a to b f of x dx. Okay, you can split the limits, that is from a to c you can take, that is the number between a and b, and from c to b you can take. Okay, fourth is 0 to a f of x dx. Okay, 0 to a, you can write this as f of a minus x dx. Okay, then if it is a to b f of x dx, you can write it as a to b function as a plus b minus x dx. Okay, so while solving definite integrals, you can make use of these properties. Then one more property, sixth one, from 0 to 2a. Okay, so this you can write it as, you can split this integral, so 0 to a you can take f of x dx, and again it is from a to a, right? So this you can write 0 to a f of 2a minus x using the previous this thing. Okay. Now there is a property for even function and odd function. Suppose the integral is from minus a to a fx dx. Okay, then this becomes 0 to a f of x dx. Okay, if the function is even, that is, if you take f of minus x, you should get f of x. Okay, so the functions like cos of minus x, you always get cos of x, right? So this is an even function. Okay, that time you can use this property, and if same number is there but the function is odd, okay, that time the answer becomes 0 if function is odd. Okay, that is f of minus x will give you minus f of x. Particular case is sine of minus x gives you minus sine of x. So this is your odd function. Okay, let's solve this problem. Now here the limit is from minus pi by 4 to plus pi by 4. That is, limit is from minus a to plus a. Okay, so you have to check for even or odd function. So this sine, we have seen sine, if you take sine of minus x, then you will get minus sine x, correct? Okay, but here the square is there. So for a square function, you can't directly integrate it. So you have to first convert it. So you can use here another method. Okay. Yeah. So sine of minus x is minus sine of x. This is right. This is a even odd function. But square is given. So if you square this function, then this will be a square. So you will get plus sine of x. So this becomes even function. Okay. So you have to use a condition for even function. So this becomes 2 times 0 to pi by 4 sine square x dx. Now use the identities. Okay, trigonometric. So 0 to pi by 4 sine square x, you can write it as 1 minus cos 2x upon 2 dx. Okay, now you can integrate. So 2 and 2 gets cancelled. So integration of 1 is x. Integration of cos x is sine 2x upon 2. Okay, so your limit is from 0 to pi by 4. Now you substitute the limit. So this will be pi by 4 minus half sine 2 into pi by 4 minus 0 minus sine 0 is 0. So this term becomes 0. Okay, so the final answer is pi by 4 minus half sine pi by 2. Sine 90 is 1. So this is your 1. Okay, so final answer is pi by 4 minus half. Okay, let's solve this. So here you can use the property 0 to a f of x dx. You can write it as 0 to a f of a minus x. Okay, so here a is pi by 2. So this you can write 0 to pi by 2 root of sine pi by 2 minus x upon root of sine pi by 2 minus x plus root of cos pi by 2 minus x dx. Okay, so 0 to pi by 2, this is nothing but sine pi by 2 minus x is cos x, okay, upon root of cos x plus root of sin x. Okay, now this is your integral. This you take it as 1 and this you take it as 2. Both are same, right? This is your I and this is also your I. So adding 1 and 2. So I am adding this term to this term. Okay, what I will get? So I will write here only plus root of cos x upon root of cos x plus root of sin x. Okay, dx. And the left hand side will be 2i. So I will write here 2i. Okay, so 2i equal to, this will get add up, so both the terms are same in the numerator and denominator, so we will get integral 0 to pi by 2 1 dx. Okay, so 2i is, this is x, so you have to take from 0 to pi by 2, which is pi by 2 minus 0. So 2i equal to pi by 2. So 2 comes here, so this becomes pi by 4. So answer of this integral is pi by 4. Okay.